So welcome back in the part 2 of this lecture. So we will discuss about the next notable environmental pollutants. We have the volatile organic compounds. So volatile organic compounds, by its name, it's a volatile. Of course, they are low molecular weight organic compounds. So they are usually present in the atmosphere, and they come from usually fuel exhaust. So evaporation of gasoline fuels, you have fuel exhaust from cars and even the factories. So VOCs in the environment, there are actually a wide range. So there are many different types of VOCs. So they have a wide range of physical and chemical properties. But one thing in common, again, they are highly volatile. They can easily evaporate into the surroundings, even at room temperature. So their half-life range from a few minutes to several months. Because again, they have a variety of structures and physical and chemical properties. And because they are volatile, they can travel great distances in the atmosphere. So, for example, the smoke exhaust from Metro Manila, they can also travel out to the Manila Bay, far out to the sea, in the Manila Bay. So in terms of the human health, the VOCs, some notable VOCs with threat to human health, they include the benzene, toluene, ethylbenzenes, and the xylenes. So these VOCs enter the body mainly by way of air or through our skin. So we usually inhale them. So they cause symptoms that may lead to pathologies including asthma, atopic dermatitis, and even neurological problems. Actually, perhaps they might be the reason why jeepney drivers in the Philippines usually have bad tempers. Who knows? But anyway, they are known to also cause neurological issues or problems. So, other examples of VOCs, we have the benzene, 1,3-butadiene, and vinyl chloride. They are classified by the International Agency for Research on Cancer as very carcinogenic for humans. So, those are VOCs. They are actually organic compounds, and they are there's a wide classification of them. But generally, you find them in exhaust, gas exhaust from diesel engines and even factories. Actually, not only diesel engines, internal combustion engines in general. Okay, so the next one are the particulate matters. Particulate matters, they are usually airborne. Particulate matters consist of a heterogeneous mixture of solid and liquid particles suspended in the air that varies continuously in size and chemical composition in space and time. So like VOCs, they are it's actually a class. There's a wide range of different types of particulate matter, and they have different properties by itself. So unlike the VOCs, by the way, PMs, these particulate matters can be both organic or inorganic. So they can be classified as coarse, of sizes less than 10 micrometers, or the fine particulate matter of less than 2.5 micrometers. So for the coarse particulate matter, which have a diameter of less than 10 micrometers, they are usually resuspended dust, soil dust, street dust, coal and oil flash, metal oxides of silicon, aluminum, magnesium, titanium, iron, calcium carbonate, NaCl, sea salt, pollen, mold spores, and plant parts. So they are usually from the suspension of soil tracked into roads and streets, basically alikabok. So you have suspensions from disturbed soil in farming, mining, the suspension of industrial dust, construction, coal and oil combustion, and even ocean spray. So they have a short lifetime ranging from minutes to hours, because not only are they large, so when they usually settle down easily on the surfaces. But again, since they are coarse, they have a larger diameter. Their distance traveled are not really very large. But let's look at the fine particulate matters. So these have diameters of less than 2.5 micrometers. So they're usually the sulfates, the nitrates, the ammonium ions, hydrogen ions, elemental carbon, organic compounds, PAH, polyaromatic hydrocarbons. You have the metals, particle bound water, and biogenic organics. So they are usually from combustion of coal, oil, gasoline, transformation products of the nitrates, SO2s, and organics, including biogenic organics, such as terpenes, high temperature processes, smelters, and steel mills. So unlike the coarse particulate matter, they are usually, actually this one is more problematic in terms of the adverse effects to human health. So their lifetime in the air, of course, since they are very fine, ranges from days to weeks. So they can remain suspended in the air for a longer period of time, and because they have a longer lifetime, they can have greater travel distance, as well as being smaller, so they can easily travel through the atmosphere. So they can travel distances of 100 to 1,000 kilometers. So those are what are the health impacts of the particulate matters. So they can cause premature death, hospital admission, emergency room visit, asthma attack. Actually, one of the most problematic is the asthma attack, chronic bronchitis, cancer, cardiovascular diseases, diabetes, and of course, restricted activities. Okay, so those are particulate matters. Now, let's look at the more technical terms or technical members of the list, the PBDEs, and later on the PCDD and PCDF. Now, PBDE stands for polybrominated diphenyl ethers. So they are, this is the structure. So they are actually polymers. Polymers with containing your bromine structure. So they are widely used flame retardants in most consumer products and electronic equipment such as your laptops, computers, and smartphones. So unlike one thing about PBDEs, they are not chemically fixed to the material, so they are easy to leach off from those materials. And as flame retardants, of course, they are just surface coating, which are easily leach out. So they have a long half-lives. We're talking about years before they can be degraded. So they are actually considered a POPs, persistent organic pollutants. Again, and also one of the reasons why they are POPs is because they are polymers. So they are known to persist in the environment and the human body. One thing about being a POPs is because they can be accumulated inside the body. So what are the exposure pathways for PBDs? Ingestion, inhalation, or even skin contact. So for the ingestion, we usually have it in our the milk, even in the food we eat, and then through the hair, adipose tissues, placental tissues, other tissues, and the serum. So what happens then? So they have, of course, they are also considered, or even the byproduct of this one can be an EDC, an endocrine disrupting compound. So of course, leading to what are the adverse effects, of course, of EDCs. Can also lead to cancer and even developmental effects and even destruction of our DNA. So those are the possible outcomes for PBDs. Now, what are the PCDDs and PCDF? So these are the polychlorinated dibenzopidioxins for the PCDD, and PCDF is the polychlorinated dibenzofuranes. So there are the two classes of the quasi-planar tricycles of aromatic esters. So they are also known as dioxins. So these are the structures. So these are quasi-planar, again, because of again, you have aromatic rings here, and they are polymeric. So you have polymers containing aromatic rings, and they're quasi-planar because, again, the structure that the ether that binds the two aromatic rings, basically you have the geometry of that. Of course, the aromatic rings are planar, but the ether binding them are not exactly planar. So you have a quasi-planar structure. So that's PCDD and PCDF, or from now on we will call them dioxins. So dioxins are classified also as, like the PBDEs, they are POPs, persistent organic pollutants. And we usually see them as industrial byproducts. So unlike the PBDEs that are usually material coatings, because they are flame retardants, POPs, or rather the dioxins, are industrial byproducts. They're found throughout the world and in the environment, and they accumulate in the food chain because, again, as persistent organic pollutants, they do not degrade easily. So they tend to accumulate. So mainly in the fatty tissues of animals. So they are highly toxic and can cause reproductive and developmental problems, damage the immune system, interfere with the hormones, and also cause cancer. So one thing in common about this in these environmental pollutants is their ability to cause cancer. So basically, those are the organic pollutants that we will be discussing in this lecture. So further reading, you can look at the following journals. And actually, I'll give references because these are the sources in making this short lecture. So you have these reference journals. So thank you for listening. See you next time.